Hi, this is Paul again. I've got another interesting video to show you. On this video, I'm calling 3D Platonic Order No Chaos 6. And in this video, I'm going to show an interesting concept which I call Phi-Noventa. In my last video, which I called No Chaos 5, there was a phi rectangle for the dodeca and a phi rectangle for the icosa, and they would work on the same plane. And first I'll show the size 1 icosethas and the size 3 icosas. And now I'll just show the outlines. And you can see that all them colored icosas were represented by just phi rectangles. Okay. Let's turn that two-dimensional plane into red. And we can also change all the outlines into white. And for this little demo, I'm going to change the camera view. I'm showing a lot of white, so I better change the dodeca color to orange. Okay, let's give it a go. Now look what happens when I start making copies and rotating it to 90-degree positions to each other. Now you can see that everything is sloping, but we've got a perfect up and down, left and right, forward and back. And you can see that the corners inside are just like that of a box. Maybe 4 or 5 more intellectuals in the world will take a look at this, because in the last 8 years, not one professor that teaches chaos has ever mentioned the words 3D Platonic order. It seems the pathway to 3D order has been clogged for many years by two-dimensional theorists that look at anything in 3 dimensions and say, oh, we've got chaos. I'm getting carried away. Now I'm going to call this assembly the Phi-Noventa. I think I should give it a posh Latin name. Now look what happens when I rotate it 120 degrees. First we've got the 1, 2 and 3. Now we'll rotate it 120 degrees. And this will give us the 4, 5 and 6. And now we'll rotate it the second 120 degrees. And that will give us a 7, 8 and 9. That's a bit around the corner. I'm sorry about that. Okay, now I'll go back to the start again and show you that I'm making 3 copies. Now you can see that the 3 copies are covering all the vectors of the dodeca. Isn't that something? This is another example of the dodeca being a wonderful 3D processor. Okay, let's look at this Phi-Noventa simple. I show the Phi-Noventa in a 0 position. And I've given 6 white edges for the dodeca and 6 purple edges for the icosa. Now I'll rotate it 120 degrees. And you can see that we get another 6 white edges and 6 purple edges. So now we'll give it another rotation of 120 degrees. Now you can see we get another 6 white and another 6 purple edges. Now what is amazing about this is that 3 Phi-Noventas at 120 degrees about the center axis gives us the full vertices of a dodeca and the icosa. Isn't that something? Now there's something else. The dodeca and icosa, I would say, is a juntos. They seem to be produced at the same time. I showed in my earlier videos that the cube size determines the size of these 2 pieces together. Now I'll just show you the white edges and the dodeca. Now take a look at these edges. Now we have sufficient edges to give you the full vertices of the dodeca. In my earlier videos I showed this part as the Phi Yucatan. So I think I better show it to you. And I'll give it a little spin around for you to take a better look at it. Now I showed in my earlier videos that the ADNA rungs are between the top and bottom Yucatan. And I showed that they use the vectors to the center point of the dodeca. I showed that these rungs going around the golden ratio Yucatan is what gives you the ADNA. Why doesn't any professor ever make a comment about this? why doesn't he say how it comes out of chaos? I don't think he'd want me in his class. Anyways, let's go back to the white edges on their own. I think this is an ideal arrangement to put the numbers of 369. Now I'll put the numbers like I did earlier on. This is just one half. The other half of the numbers goes the opposite way, just like on the Lorentz effect. So I show the other set of numbers in a different color. And I think I'd better give it a yellow 0 on the top and bottom also. Now what I'm trying to say, how does the Lorentz effect prove that everything is chaos? Because I am showing accurate geometry that gives the same effect. Rotation positive and rotation negative. Maybe nobody should question a mathematician because he can give you a F minus. But what he's got is just a theory, and what I show is 3D reality, and it should not be snubbed because of intellectual discrimination. Okay, let's just go back to the edges again, and I'm going to bring in a solid size 6 icosa. Now let's give it a spin around and take a look at what we've got. In front you can see we've got a size 6 icosa and a size 6 dodeca outline. Now I showed in my earlier videos the lessons 1 to 10 and these videos that show a wonderful 3D Platonic order without any chaos. I've also showed the measurements which are very simple between phi and the cube. I also showed that the vertex of our icosa sticks out a little bit, what I call a slimbo nipple on the face of the dodeca. Let's take a look. And now we can give it a little spin around also. I found this limbo gap when I was working on BDNA, and it can also be shown by two small nipples which I call slimbo nipples. Now if you follow the geometry of my lessons 6 to 10, I show how important these nipples are in the geometry between the dodeca and the icosa. It looks like very few people are interested in 3D geometry. It's a shame. But the slimbo gives you 3D Platonic order without chaos, and it gives you the BDNA. I've got one more thing to show you. Let's look at that anim of the Phi-Noventa again, because I spotted something that could be useful for some people in the future. 2 or 3 years ago I showed the geometry for ZDNA and it came out of a sloping rectangle. Let's hide the red rectangle. I've changed the colors on that sloping rectangle for ZDNA. I show the vectors and the size 1 rectangles in purple. And by now, if anybody is taking an interest, they should know the size 1 rectangles can be turned into icosahedrons. And I showed in my earlier ZDNA that this geometry will give you the molecules. Now what is interesting in this setup is that green rectangle for the dodeca uses the vectors for the ADNA. I'm not showing the sloping rectangles, but they will be using the same vectors as the green rectangle. But what I'm getting at is that blue rectangle for the icosa that gives you the ZDNA is related in perfect geometric form to the ADNA. So the molecules are all interrelated. I think we've got some real serious stuff here for molecules and stuff for DNA. I think these two-dimensional theorists with all the big words and stories shouldn't have nothing to do with this stuff. They should be turned over to people like engineers. Because I really think it's pathetic the way these people look at three-dimensional geometry. They've got no interest whatsoever. Because if you want to work on DNA, it's in 3 dimension. Only an idiot would look at things in 2 dimension. and I've showed that the basic measurements and everything for three-dimensional Platonic order is very simple, and it wouldn't be very hard for children to understand. So for those that like to look at things in 3 dimension, this is Paul saying thank you very much for looking at my videos.